Morning, everybody. Yeah, this seems to be working. So, welcome to week number seven. Okay, so we can't have a live class right now because of your second practicum or practicum, whatever you want to call it. Next week, at least weeks 8 and 9, we'll have a live class. So hopefully that'll help a little. In the meanwhile, and most of you have been reaching out to me, if you really need any kind of direction, if you're feeling lost in terms of anything, I'm here on MS Teams. We can set up a time. I'm trying to, put this message across as many times as possible. Please don't feel shy. This is not a semester where feeling shy is going to help. Please approach me. Now, obviously, I'm working on other things, but I'll do my level best, especially given this particular semester, with me and you having zero contact in terms of actually, getting to know each other. That level of comfort is not going to be there. Till last semester, students just used to walk up to me, and that was easy because coming up to somebody and talking is probably not very difficult, but approaching somebody on Teams is a little bit more difficult. So again, if you have problems, and I'm assuming you will have problems, I've had probably in a class of 150, I've had about 40 or 50 people talk to me. That's about it, which is relatively low. But then again, maybe given that you have access to these videos, you are feeling more comfortable. So whatever it is, I don't know. So if you have any problems, please get in touch with me. Primarily through MS Teams. Don't try the other means. I've had people trying to contact me through UNSW Moodle. That's the last thing you want to do because Moodle refreshes overnight, so I don't get your emails instantaneously. Okay, so please make sure that you don't use that. Other than that, preferably not emails. Teams being the most versatile software in terms of what's happening right now. Okay. I'm assuming everything's recording. Okay, so let me walk you through a few things before we go any further. The first thing is, let's have a look at your Moodle. So this is your Moodle page. So one more thing is going to become available to you today, which is beer consumption. Okay, and probably I would also want to have a look at grade comparison. So the two of these are what will become available to you today, and two corresponding questions. I'll probably have a look at those questions next week when we have a live class, but please feel free to work with them. They're going to be relatively easy, so not really too much of difficulty. Now, there might be some errors in terms of how data are coded in the two files. Don't worry about it. Okay, your intention is to look for differences given the data. The data, in fact, the ones that you're going to get in beer consumption, that's actually going to be a little incorrect. Okay, but again, don't worry about it. Just go ahead and run the test anyway. Okay, so that's one. The second one, that's grade comparison for repeated measures ANOVA. Now, repeated measures ANOVA is not something that I'm going to test you on in the finals. Okay? Primarily because it's a little bit difficult running it, and it's a test that's fraught with a few problems, and very soon, in fact next week, we'll have better tests that are going to be available to us. So but having said that, if you want to practice it once, I would really suggest that you do. That's probably going to be the best way to go. One more thing. Week 8, you will have the 2 extra credit surveys made available to you. Please make sure you go ahead and do those if you want to. Just confirm how the extra credit works, because I am not involved in that process altogether. Somebody else is going to be giving me links, and all I do is put these on. Confirm on your syllabus, your course outline as to how you will be given credit. These are not 3 extra points. These are 3 points which replace your final grade. So not your final grade, your final exam, which is your final practicums grade. So have a look at it. It's explained very well in the course outline. It goes through a process that's vetted by the ethics committee. So just we want to be very careful on those. Okay. The remaining two, job satisfaction and life satisfaction, they are going to be opened up after 2 weeks. So we'll hold off on those. I'm hoping you are getting along well in your project. I know it's a little difficult with all of you on different sides of Sydney, or probably even the continent, or probably even the world. So just try and do your level best. And I will obviously take the fact that you can't work in groups physically into account. So I'm not going to hold you to the standards that I've been holding students to till, let's say, last semester. Okay. Again, I know the problems that are going on, and it's difficult to, and again, I can't step into your shoes. It's difficult for me to figure out what you are going through, but I have hopefully a relatively good idea, because I would hate to be at the other end too. In fact, I hate being on this end, but I would really hate it more being on the other end too. So I'll take all of that into account. Obviously, the university is also going to be a little bit lenient, but the curvature, which means that I have to look for an average of around 65, that can be flexed around a little bit. Anyway, we'll figure that out once we come to it. But please be aware that I know what you're going through, so just make sure that you do the best job you can. But after that, I'm here. I'll try my level best in terms of whatever I can. All right, now let's go to the the two sets of slides that we're going to go through today. I'm not going to look at slides again, because in a class these might make sense. In the class setting it might make sense, but in this recording sense, I don't think slides make sense. I probably will put myself to sleep rather than putting all of you to sleep. So I'm going to stay away from this. You have a look at these. My focus is going to be just drawing on PPTs as I have till now, and then run the tests, give you some examples of how a manager could look into these, and then run some tests. So there are two sets of slides. You should go through the slides, because it also gives you a little bit of a statistical background. I'm not going to test you on that. And again, the question has come up multiple times. Are we going to be tested on what's happened in the tutes or what's happening in here? It's on what's happening in here. It's never going to be on what's happened in the tutes. As an example, I don't look at the 20% for ANOVAs. For chi-squares, whereas that has been looked into by tutors. Some of them haven't. It doesn't make a difference. You focus on what you have done. So those boxes, if they have a low count, that's fine, because we are not trying to thread the needle out here. We are trying to give you a big picture. The threading the needle is going to happen as you go through into higher level courses. Okay, so those are the two sets of slides. Module 4, which looks at ANOVA setup and analyses. I've introduced you to ANOVA a little bit last week, but today we are going to go through that in a lot more detail. And Module 5, which is probably the shortest module, which is looking at repeated measures ANOVA. Okay, so those are the two sets of slides that you look at. I think they are explained very well in here, but that's primarily the background. I've given you some examples of what the null and the alternate can be, but this is the time when we are going to switch away from the null and the alternates. Remember, the null is always going to be, there is equality. Some groups are equal to each other. All groups are equally important. Look at this. All attributes in this case are equally important. In ANOVA, all groups are equally important, and the HA is going to be at least one group, at least one attribute is different from the other. So there's at least one inequality in the alternate. That's all that you need to look at, but we are going to look at it in a little bit more detail. Again, I'm not going to ask you about H naughts and HAs. Once you get to ANOVA, correlation, regression, we are not going to look at those. So these are the two sets of slides. This gives you a very good idea. Again, tries to stay away from what has not been done in class, because in the lectures, because again, statistically this makes perfect sense. And if I were teaching you a 14-week class, which I did in the US, for example, it would probably make sense to go a little bit through this, but not in a 10-week, in fact not even a 10-week, a 9-week course. All right, so let's go on to where we were. I am going to open a new presentation. And we are going to go back to our boxes. So we have segments, we have questions, number of groups, if you want to call it that, number of groups, attributes, whatever you want to call them. We have been working with one categorical, which is the categorical variable. There you go. Categorical variable. It can be nominal or ordinal, and one or more continuous variable. Sorry, one continuous variable. More because we can analyze them at the same time. Now, when we started off, we went with, I go through this really fast every single week probably because it's really important for you to be really clear about this. So number of segments is 1, 2, greater than 2, y greater than 2, because at some point of time we are going to change this. Greater than 2, however, can be grouped together. And then you have number of questions, 1, 2, greater than 2. Even if this seems repetitious, I think this is very, very important in terms of solidifying your skills. So one sample t-test, I'm going through this a little fast. Two groups of people, one question, independent samples t-test. One group of people, 2 questions, repeated measures t-test also, and I'll tell you why I'm introducing this term, repeated measures t-test in a second. Also known as the paired samples t-test. Repeated measures t-test, paired samples t-test. Now, what I had introduced to you last time was, if the number of groups is greater than 2, then we use ANOVA, analysis of variance. One single question, but the number of groups is greater than 2. What I'm going to also introduce to you today, we are going to spend a lot of time on ANOVA, and then we are going to move on to this box. And this box is known as the repeated measures ANOVA. Okay. If I were, let's write this outside so that it looks a little better. Repeated measures ANOVA. Now you can go back and see why this is also known as a repeated measures t-test. A repeated measures t-test, or a paired sample t-test, 2 questions. More than 2 questions, it's no longer a t-test, it becomes a repeated measures ANOVA. So that's the grouping of the 2 tests that we are going to look at today. Once we are done with today, this box goes away. It'll come back later when I recap the entire thing and put everything together. But this box is going to go away. Why? Because we have looked at all possible scenarios, 1, 2, greater than 2. 1, 2, greater than 2. We've looked at all possible scenarios when we are working with one categorical variable and one continuous variable. What we are going to start off doing next week onwards is 2 continuous variables. So this box fades into oblivion. It comes back again as a recap. It's not an unimportant box, it's a very important box given the kind of surveys most of us run. When you get into more advanced territory, we are going to work with one continuous, one categorical, and that categorical is going to be a different type of categorical, multiple categoricals, multiple continuous. This box is going to keep on expanding. But this 2-dimensional simplified version is probably the last time you are going to see it, okay? Except for the recap. So those are the 2 tests that we are going to look at. What about in here? What about in here, in here, in here? Those are very specific cases that usually do not happen. Okay. The answer is ANOVA can in one manner or form address all of these, but we are not going to look at those because they are very, very specific scenarios, and we usually have a better answer, a better test for all of these, which we are going to look at. But 1, 2, 3, 4, 5 boxes are the most important part of the first part of the semester. Okay. All right. So let's start off with ANOVA. What was ANOVA? ANOVA was the number of groups is greater than 2. That's my categorical variable. It could be ordinal or it could be nominal. Either of those is fine. Okay. The second one is the number of questions is just 1. So are people, or are 3 groups of people, are 5 groups of people different in terms of how they evaluate a question? Okay. Notice 3 groups of people, 5 groups of people, 7 groups of people, not 2 groups of people. If it's 2 groups of people, we have independent samples t-test. Okay. So we are looking at more than 2 groups. I'm going to remind you of something in here, and then I'm going to completely disregard it and run some tests anyway, which is if the number of levels in an ordinal variable is 5 or greater, what can you assume? You can assume that it's a continuous variable. Okay. If you can assume that it's a continuous variable, then we are playing with 2 continuous variables. No longer are we playing with 1 categorical and 1 continuous variable. Okay. We are playing with 2 continuous variables, in which case we are moving to another domain, which we start working on next week onwards. So if we have income less than 50,000, 50,000 to 100,000, greater than 100,000, excellent. 3 groups, it's an ordinal variable. Okay, but 3 groups, so I cannot assume it to be continuous. On the other hand, if I ask you 5 groups, less than 25,000, 25 to 50, 50 to 75, 75 to 100, and greater than 100. Now I have 5 groups. Now I can assume it to be continuous. Okay. What if I have 5 races? I can't, because there is no order to it. If it's a nominal variable, it's always going to be a nominal variable. Okay. It's never going to become continuous. It's always going to stay categorical. Please be careful about this. This is one place where lots of people face a difficulty. Okay. All right. So let's move on to a test, let's say. Let's look at one of the variables that is available to us. Okay. So one of the variables that's available to us is income. What is income? How is income calculated? Income is collected in groups. Income is collected in groups. Okay. Now, let's go back and open the data set. I think I have it open. Yep, I do. There you go. Let's close. I have too many windows open. Okay. So let's look at income. How many levels does income have? 4 levels. What kind of variable is this? It's certainly a categorical variable, but is it ordinal or is it nominal? There's a certain order to it, which means income is going up from 1 to 2 to 3 to 4. Income is going up, which implies, what does it imply? It implies that it's an ordinal variable. There's an order to my variable. On the other hand, instead of this, had I taken, there you go, type of car, 1, 2, 3. American is first, European is second, Japanese is third. I could easily have said Japanese is 1, American is 2, European is third, and it wouldn't make a difference. There is no order in this entire data set, in this entire variable. So this is not a variable which has any order, and hence it's a nominal variable. Okay? But we were looking at income. And let's start doing something before we run our tests. This is where intuition, and this is where, just experience or whatever you want to call it, the fact that most of you have been living on this earth for the past 20 years, you've absorbed something from the surroundings, whatever it is. The fact that your mom has told you something, the fact that your dad has told you something, the fact that your siblings have told you something, the fact that your classmates have told you something. So income is a variable which defines how much you earn. Now, if income is a variable which defines how much you earn, and I'm just going to simplify it, I have people these are people who have bought a luxury car, so they're obviously not extremely poor, but there are some people who have reported earning $50,000 or less. So let's suppose there are people who earn a low income and there are people who earn a high income. I have more categories. I'm just simplifying it for the sake of presenting this to you. Now there are categories in the middle too. Let's have a look at our data. And there are my attributes. So those are my 12 attributes. For a person who has low income compared to a person who has high income. Okay, I'm looking at income. Why am I looking at income? No reason, just decided to. Which of these attributes do you think are going to be valued differently? Okay. Comfort, you can probably say, and again, I'm nobody to say you're wrong, I'm nobody to say you are right. Comfort, I don't see any reason why a person with higher income is going to give more importance to comfort as compared to a person who has low income. You might have some logic behind it, and again, like I said, there's no reason for me to say that you're wrong, but I don't believe so. Okay? So I don't think there is any reason for there to be any difference across the groups, rich and poor. Safety, again, I don't think so. Okay? If you have some logic to it, please feel free to test. What about power? There is actually research to show that the lower your income, the higher the chances that you require more power out of your car, primarily for showing off. Okay, so let's suppose there is something in here. Speed and power kind of go together. Styling also goes together. Okay. People who have a lower income are more into showing off. That's the truth, whether or not you believe it, unless you get to the very top of the scale. So it's what we call a U-shaped curve. A U-shaped curve where people who are relatively rich don't like showing off. People who are relatively poor do. People who are extremely rich, again, are very ostentatious. Not true in every single thing, but obviously there's a relation. Durability. Okay. People who are poorer would like a car to be more durable. That's what my logic would say. Low maintenance cost. That's what my intuition says. Again, people who have lower income want to spend less, so they want low. Low maintenance cost. They want the car to be reliable. They want a higher warranty just in case something goes wrong. Non-polluting, I don't know. Again, are richer people more environmentally friendly? Are poorer people more environmentally friendly? I don't have, based on my intuition, not based on my research, but based on my intuition, I have no idea. So I probably don't think there's going to be too much of a difference. Gas mileage, absolutely. People who are poor, they want higher gas mileage. People who are richer, they don't care about gas mileage. $1.50 for a liter of gas. That's not too much. Repairs, this is the speed of repairs. Okay. And this is one of those variables which is a problem in every single place. Do you believe that there will be a difference? If I were to be asked this out of the blues without knowing the data set, I would say probably yes. The richer people would want the cars to be fixed quickly. The poorer people probably not as much because they are fine, taking the public transport, let's say. But then somebody might say, a person who is rich probably has multiple cars and they don't care about speed of repairs. So I don't really have an answer. I don't have a solution to this. So what should I do? Go ahead and test it. It's so easy to add a new test that you can just go ahead and test it. That's all that you need to do. So what's the hypothesis going to be? I'm not going to ask you to write a hypothesis, but what is the hypothesis going to be for any of these tests? In an ANOVA, the hypothesis is really easy, and this time it's the null that's easier to write. Okay? It's the null that's easier to write. For t-tests, it's always the alternate that's easier to write. For ANOVAs, it's the null that's easier to write. What does the null say? I'm going to give you a generic form first, and then we will look specifically at the question that we are considering. So the question's importance does not vary across segments, which means all income groups value comfort equally. Okay? All income groups value comfort equally. Notice that H0 says everything is equal. So all the equalities are going to be in the H0. What does the HA says? What does the HA say? The HA says at least one segment values the question, sorry about that, differently. It's not saying that all groups are different from each other. It's not saying that all segments are different from each other. They might be, but all I'm saying is at least one of the segments is different. At least one, which means your HA can have multiple equalities, but it's got to have at least one inequality. See the difference between t-tests and ANOVAs? So in ANOVAs, there can be an equality in the alternate, but it needs to have at least one inequality. At least one. It might have more inequalities, but it's got to have at least one. That's why it's so difficult to write this using H0 and HAs. It's very difficult to write it, which is why I probably won't even ask you to write the alternates and the nulls. Okay? That's not what the focus is. So question's importance does not vary across segments. At least one segment values the question differently. So let's look at comfort. What did comfort say? Comfort across income groups. My alternate is the importance of comfort varies across income segments. Okay. The implicit in here is at least one. Okay. The importance of comfort varies across income segments. What's the null? The importance of comfort does not vary across income segments. That's it. Okay. But again, this needs to be at the back of your head. You should be able to formulate these now. Relatively easy to do. Null, everything is the same. Alternate, at least one group is different. Null, at least one of the null, all the segments are different. Alternate, at least one of the segments is different in the evaluation of the question. Okay. Now let's go back to actual practical implementation. What did we see in here? We thought that we would see a difference in gas mileage. We would see anything related to money, we are going to see a difference. Gas mileage, maintenance cost, durability, those seem to be, reliability, warranty, those seem to be the things where consumers differ in terms of importance. This is what my intuition tells me. Okay. So let's start off with first a single ANOVA. Unlike the t-test, this is a multi-stage process, and you know why. Okay. We'll start off with a single ANOVA and then expand it to do multiple ANOVAs at the same time. And that's what you should be aiming for. You should be able to run a lot of ANOVAs together and then come up with the results fast. Okay. So let's start off with one of the things which we thought might be different, which would be power. Okay. Does power differ? Does the importance of power differ across income groups? Does the importance of power differ across income groups? My alternate is the importance of power my null is the importance of power does not differ across income groups. What is my alternate? The importance of power differs across income groups. Notice that I have not said which income group is different. That's not something that I want to do. What I want to do is just one of them differs. Which one differs? We'll figure it out. That comes in later. So let's run this test, and we ran this test last week. What we did was a very rudimentary type of ANOVA. We're going to go into a lot more detail today and look at all the steps. Step 1 for all ANOVAs is going to be run the ANOVA. Run the simple ANOVA, which is last box in here, which is compare means, one-way ANOVA. Okay. What we are looking at is the importance of comfort. So that's the question being analyzed. What is the factor? The factor is income. Remember last time I told you, factor is a statistical term which for us in marketing implies groups of people or segments. I'm not going to touch any of these right now. Actually, we're going to be touching the two of these, but not right now. First step in an ANOVA is just run the ANOVA. That's it. Press OK. And what do we need to look for? We need to look for the p-value. Is that less than 0.05? No, it's not. Your ANOVA is done. Your ANOVA is done. You are done with your ANOVA, which is there is no difference across the groups when it comes to the importance of comfort. If the p-value is greater than 0.05, you're done with your ANOVA. That's all that you need to do. Okay, that's all that you need to do. What is it that you need to do? Run the ANOVA, p-value greater than 0.05, stop. Other steps are not needed. So what am I going to accept? My null or the alternate? We are going to accept the null. Always when p is greater than 0.05, we accept the null. What was the null? The importance of comfort does not vary across income segments. That's it. The importance of comfort does not vary across income segments, which means all the income groups that we have in our data value comfort equally. Stop. We're done with the test. Let's try a different one. Let's try something which is focused on money. Okay. Instead of looking at comfort, let's look at gas mileage. I expect, and again I might be wrong on this, but I expect that people will differ in terms of gas mileage. Who is going to, look at it the most? Probably the people who are the poorest. Who's going to look at it the least? Probably the people who are the richest. I don't know. Okay, let's try and figure that out. First thing is there even a difference? I've already set up my ANOVA. All I need to do is press OK. Is that less than 0.05? Yes, it is. If it's less than 0.05, what does it imply? That the groups are different from each other. Okay. What was my null? My null was the importance of gas mileage is the same across all income segments. What's my alternate? The importance of gas mileage is different across income groups. So those are my null and alternate. What do I accept? My alternate. Now that I know that there's a difference across groups, I need to figure out what group is different from what. I need to know which group is different. Is it that the richest ones are different from the poorest ones different from the middle income earners? How are these people different? Okay. My intuition tells me, which might be completely wrong, is that people who are the poorest will probably care more about gas mileage. Let's have a look. Step 1, run the ANOVA. If the ANOVA is greater than 0.05, stop. If the ANOVA is less than 0.05, go to step 2. What is step 2? Go back to your ANOVA. Go back to your ANOVA, click on options. And after options, click on homogeneity of variance tests. We are not going to look at the logic behind it. All I can tell you is the correct test to run in an ANOVA is based on how spread out the answers are. Let's not worry about that. We are looking at it very mechanically, and let's continue doing that. What we need to do in step 2 is click on homogeneity of variance test. Okay. And because all of us probably work a little better when we are visualizing data, you can also say means plot. What does means plot do? For each and every group, it will plot the mean response to the answer. So the question that you're analyzing, what is the mean for the lowest income group, the middle income group, the highest income group? Just a visualization. You'll get these results anyway, but just to make it visually appealing, just to make it visually something that can be absorbed, what do? You click on the means plot. This is something which is not compulsory. Please feel free to disregard it. Press OK. So this is my step 2. What was step 2 again? Options. Homogeneity of variance test. Means plot. Press continue. Press OK. So you're going to get the ANOVA that you got last time, which is this, back again. This is going to be on your screen 3 times. Okay. The first time when you just run the ANOVA, the second time when you click on options, click on homogeneity of variance test and means plot, press continue, press OK. It's running graphics after a long time, which is why it's taking this long. Usually it takes half a second. So you notice the ANOVA hasn't changed. It's not going to change. Okay. What we are interested in finding out, what is the fact that we are interested in looking at, is the significance of Levene statistics. See this? The first one, the first row, you look at the significance. What is it telling you? Consider this to be a switch, just a switch, which tells you what is the test that you need to run to compare all the groups. What is the test that you need to run to compare all the groups? You still haven't compared the groups. You know that there's a difference across the groups, but we don't know which one is different from the others. This first number that you see in here, which is 0.569, if it's greater than 0.05, you run a different test. If it's less than 0.05, you run a different test. What is this number signifying? This number is signifying that the variation, again, please feel free to disregard this, the variation in the answers of the first group, people seem to have given answers close together, is different from the answers in the second group where people have given answers all over, is different from the answers, the variance in the answers of the third group where people have given answers that are close together. So there's a difference in terms of how close the responses are. So depending upon how close or far the differences are, you run different tests to compare these groups. So in this case, significance is 0.569, which means P is greater than 0.05. Okay. I'm going to ignore this graph for right now. I'll tell you why in a second. I'm going to ignore this graph right now because the moment you look at this 0.569, it's the first number. The moment you look at this, before you interpret any graph or anything at all, you need to run one more step. Step 1, run the ANOVA. Step 2, run what is known as the test of homogeneity of variance. Step 2, based on that, decide what test needs to be run to compare the groups individually. This will probably be a lot easier to understand once you have a look at the output. Compare means we're going back to the same thing, a third time. Every single ANOVA needs to be run 3 times if it's significant. If it's not significant, once and you're done. One-way ANOVA. Click on post hoc. I'm assuming all of you are running IBM SPSS 24 or above, the version number. So the post hoc is going to be a separate button. Click on post hoc. If P is less than 0.05, then you check on Tim Haynes. If P is greater than 0.05, you check on Tukey, not Tukey B, Tukey. What's different across these tests? Statistically, there's a lot that's different. For me as a business major, it doesn't make a difference. All these tests are going to give you pretty much the same results. In fact, most of the times, this and this will also give you the same result. And most statistical software automatically takes care of this. SPSS does not. SPSS wants to give you more control, which is fine, but it also makes the process a little bit more cumbersome. In our case, P was 0.5 something something, which means it's greater than 0.05. Hence, we are going to click on Tukey. If the p-value had been less than 0.05, we would have clicked on Tim Haynes. Click on Tukey, press OK, and you're going to get all of your results again. Okay, nothing is going to change. You have test of homogeneity of variance. You have ANOVA significance. This is useless without first looking at this. This would not even have come up had it not been for this. Let's have a look at the third new box that's popped up, which we call post hoc test. We know what a post hoc is or a post facto is. After the fact, after I have run my ANOVA, If I have not run my ANOVA, I should not be looking at these tests. It's incorrect. Again, that's a statistical fallacy, but we don't care. But we should still not be looking at these. In fact, we won't even come here if the p-value in here is greater than 0.05. Okay. So let's have a look at this. What does it have? It has the three income groups, 35 to 50, 50 to 65, and greater than 65. It has three income groups. Okay. And it's comparing each income group. It's comparing each income group to the remaining two. Each income group is being compared to the remaining two. So 35 to 50 is being compared with 50 and 65. 35 to 50 is being compared to 65. It's not compared to itself because it's the same. So this is group number 1. This is group number 2. This is group number 3. So comparing first group to second and third, comparing the second group to first and third, comparing the third group to first and second. Okay. Now what are we doing next? It is checking if the difference across group number 1 and group number 2, which is the mean of I, which is the first group income, which is in the first column, minus J, which is the group in the second column. So the mean of 35 to 50, mean of 50 to 65, I minus J, the difference in their means is 0.975. So who cares more about gas mileage? I minus J is a negative number, which means which one is a larger number, I or J? J is the larger number. So who gives more importance to gas mileage, the low income or the middle income? Since I have three groups of people, low income or middle income, and then the third one is high income. It seems that the middle income guys seem to give more importance to gas mileage as compared to low income guys. However, notice that there is no asterisk, the star, that sign that you see. There is no sign in the difference between the two groups, which means although they might be different, they are not statistically different. Statistically, I can't claim based on my sample that low income earners and middle income earners are different. What about low income and high income? Who cares more? It's a positive number, I minus J. The first number is bigger, I is bigger, which means the first group, which is income 35 to 50,000, is bigger. Right? It's a positive number, 0.327. This minus this is a positive number, which means that number is bigger. However, still no star, still no asterisk. Okay, what does that imply? It implies there is no difference between low income earners and high income earners when it compares to gas mileage. Let's look at the second set of comparisons. A comparison of the second group to the first group. We've already made that comparison up here. We're making that comparison again. Why? Because comparison of A to B and B to A are both displayed. Okay. The numbers are going to be exactly the same. All numbers are going to be exactly the same. However, the signs are going to be reversed. Why? Because now we are subtracting the first group from the second group. So in this case, we are subtracting the second group from the first group. In this case, we are subtracting the second group from the first group. Still no star. Let's have a look at the second group and the third group. Bingo. The second group, which is the middle income earners, they seem to be different from the high income earners. We already found out that they're not different from the low income earners, but they are different from the high income earners. Okay? Who cares about it more? Subtracting J from I minus J. I minus J is a positive number, which means what is bigger, I or J? I is bigger. Who cares more about gas mileage? The middle income. The middle income earners seem to give more importance to gas mileage as compared to high income earners. So the difference lies between middle income and high income, not between low income and high income, not between low income and middle income. And that's something that you should now be able to see in the plot. These guys, low income, middle income, high income. We are going to ignore this box for now. You will look at it in 3090, but not in 2052. This tells me, and it seems to make logical sense, that this and this are not different. This and this are not different. However, that and this are statistically different. Middle income earners seem to care the most about gas mileage, not the low income earners. You can think about psychological reasoning behind that, which might be that the middle income earners are the ones who are trying to maintain a good car and also maintain a lifestyle, whereas the lower income earners, their entire focus is upon their car. You can come up with multiple points of reasoning, but that's not something this data is going to tell you in any manner or form. Okay. So these are the steps of an ANOVA. You do not look at this box. Okay. Why do you not look at this box? Because it does a little bit of segmentation which is beyond the scope of this particular class. It's a lovely little box. This is something that you are not going to run if you run a Tim Haynes test. What's a Tim Haynes test? We'll come back to that in a minute. So this is when you are looking at one attribute at a time. Let's, sorry about my throat. What if we want to, and which is what we are going to do, what if we want to analyze multiple questions at the same time? We're not comparing questions. Please remember that. Just like we were not comparing questions in t-tests, we are not comparing questions in here either. There's a lovely graph in your slides, if you go back and have a look, in terms of importance of various attributes. Okay? Go back and have a look at it, but we're going to do this out here anyway. So I'm going to analyze. Compare means one-way ANOVA, and instead of looking at just gas mileage, I am going to look at all of these together. Okay. So that's 12 ANOVAs that you're running at one go. Coming back in here, sorry, I think I've deleted that slide. Yes, I have. So this is the box where you are comparing one question, multiple groups, greater than 2 groups. In this case, income has 3 groups. One question, 3 groups. But I'm running that 12 times, one with comfort, one with safety, one with power, one with speed, and so on. Okay. Multiple questions being run, but each of these is a separate ANOVA. I'm not going to click on post hoc. I'm not going to click on options right now. I'm basically resetting the entire thing. Okay. And I'm going to run this. Let's see what happens. You have 12 separate ANOVAs, and I need a sheet of paper and a pen. There we go. I have 12 separate ANOVAs. That's a lot of ANOVAs. But I can pick out the ones where I need to go further. Start off with comfort. Do I need to go further? No, I don't. Safety. Do I need to go further? No, I don't. Power, do I need to go further? No, I don't. Speed, do I need to go further? Style, do I need to go further? No, I don't. So this intuition that I said I have, which was lower incomes tend to show off more, at least in my data, there is no evidence of that. There's absolutely no evidence of that. Durability. Yes. Okay. So durability 0.018. So durability differs across income groups. Why? Because P is less than 0.05. What about maintenance cost? Not really. What about reliability? No. What about warranty? Warranty is, on the verge. So you might decide that warranty is different. I'll leave that up to you. I'm not going to look at it. Non-polluting, still less than 0.1, but not less than 0.05. So let it be. Gas mileage, yes. Sorry. Speed of repairs, no. Okay, so there's just two things that are different across the groups. So step one done. So what am I going to do for step two? I'm going to take all of this, delete it. Remember what step two is? Step two is you are going to click on options. But before I go there, what am I going to do? I'm going to take gas mileage. I'm going to keep durability, and I'm going to throw everything else to the left. See that? Everything else goes to the left. Because all the others, it didn't turn out of significance, so why do I need to go any forward? Now comes step two. For the two that turned out to be significant, click on options, fixed and random effects. Sorry, homogeneity of variance test. I'm working with fixed and random effects on a different project, so which is why that's on the top of my head. Means plot, just for visualization. Press continue. Press OK. Why am I pressing OK? Why am I not going to post hoc? I know that for gas mileage I should be running a Tim Hayne. No, sorry, it was a Tukey. What about durability? What should I be running? It's possible that I need to run two separate watts. Press OK. Durability, the variance seems to be different. P is less than 0.05. Gas mileage, P is greater than 0.05. So these are the two numbers that I'm looking at. That's number one, that's number two. So for one of them, which is durability, I need to run a Tim Haynes. P less than 0.05, I run a Tim Haynes. For this guy, P greater than 0.05, I run a Tukey. See the difference? So we are going to be running two separate tests. How can I do that? Because if I go to, let's get rid of this output. If I go to one-way ANOVA, post hoc, how do I tell it to run a Tukey for one and Tim Hayne for the other? You can't. You can in other languages, but you can't in SPSS. So what I'm going to do instead is take away the analyses that I've already done, which is gas mileage, and run this only for durability. And for durability, we should be running a Tim Haynes test. Continue. Results are going to be, the output is going to be very, very similar. The only difference is, notice that segmentation box that I was telling you about, which I was asking you to ignore. That is not an output in Tim Haynes. That is an output for Tukey. It is not an output for Tim Haynes. So let's see. Let's do a comparison. Group 1 versus Group 2, are they different? No, they are not. Group 1 versus Group 3, are they different? Absolutely. Group 2 versus Group 1, are they different? Nope. Group 2 versus Group 3, are they different? Yes. And Group 3 seems to be different from both of those. And what you get in one is exactly the opposite of what you get in the other. So who cares about durability and who doesn't? You can look at the science and figure it out. Alternatively, you can just look at the means and figure it out. These guys, which are the rich guys, don't care about durability. I'll buy one car this year, I'll buy another car 4 years down the line. These guys, on the other hand, care about durability. They are earning less, so they seem to care more about durability. So I've run a quick ANOVA. I've taken all the attributes and I've figured out these attributes, they differ across income, but just two of them. All the others, they don't. So what can I tell the marketing manager? What can I tell the marketing manager from a result like this? Let's have a look at just this result, which is durability. This needs to be converted into something that a marketing manager can change in the 4 Ps. So what can I do? Promotion. Advertise durability. Which groups? Low income and medium income. Okay. If I know a person's income, if I have some idea of a person's income, I advertise the concept of durability. Or if I know that the person who is driving into my showroom in a Maserati probably is in this income group, so this guy doesn't care about durability. So sell the right promotion. You are selling the correct promotion. What about product? Make your product more durable if it's focused on these guys. If it's focused on the creme de la creme, there's no reason to focus upon durability. So you're not going to see a Maserati ad or a Mercedes ad or a Volvo ad which says it's going to last you forever. No. You're not going to see a 5-year, 500,000 mile, 500,000 kilometer warranty on a Mercedes. Now it's 3 years, take it or leave it, because durability is not a concern. Okay. So you advertise accordingly based on these results that you get. What you have right now are very simplistic scenarios. As you go up all the way to 3090, you will see all of this developing. Your advertising strategies, your product strategies are going to get very, very different. Before we move on to repeated measures ANOVA, I want you to look at one more thing, and I'm going to go through this really fast, more about the process. I'm not going to explain every step because you have to do a few of these yourselves. There is no way by just looking at the lectures that you can master all of this content. So what I'm going to do now is look at the difference on these attributes. I've already looked at how they differ across income. I'm going to look at how they differ across, age. Is there any attribute, the importance of which varies across the age of a respondent? No post hocs, no options, nothing. Press OK. No, 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 yes. Non-polluting, there seems to be a little bit, but nothing else. The only thing that people vary on is the speed of repairs. Now, I've seen so many, surprising results for speed of repairs. People don't say they don't care about speed of repairs, but when it comes to satisfaction, they're unhappy with the speed of repairs and so on. And now this seems to vary across age. So people vary across them, so that's the only attribute that's of importance. I'm going to go back in here and delete everything except for speed of repairs. Step 2, I need to run a homogeneity of variance test and mean sort if I want to. Continue, press OK. 0.434. Should I be running a Tukey or a domain? I should be running a Tukey because P is greater than 0.05. So let's run a Tukey. Let's delete all this. Analyze, compare means one sample, post hoc, Tukey, okay. So 5 age groups. I could have assumed this to be continuous. I have not assumed that to be continuous as of right now, but 5 age groups. There seems to be a difference between age group 1 and age group 4 star. There seems to be a difference between age group 4 and age group 1. All other groups seem to be the same. So the difference lies only between age group 1 and age group 4. This box in here again, which we are going to ignore. So age group 1, which seems to care about speed of repairs the most, and age group 4, which seems to care about speed of repairs the least. These guys, they are young, they are on, it's all about their career, so they have to have their car with them all the time, moving around, a very fast lifestyle, kids at home, etc., and so on. So they want their cars to be fixed the fastest. These guys, 56 to 65, probably getting to be empty nesters at the fag end of their careers, pretty much ready to retire. They don't care. They want to take life slow. Why does it increase? Well, statistically it doesn't seem to increase 65 and over, but probably these guys are in a hurry to get back, so that mortality salience, they're getting close to that, so time starts becoming a little bit important again. But the difference seems to lie between the youngest and the 56 to 65 age group. Okay. So I'm going to give you a little bit of a homework, which is, you already know your data. Sorry. You've looked at how the attributes differ across age groups. I want you to look at how values differ across age groups and how values differ across income. Okay, so have a look at those. That's something that you can use as a practice exercise. Obviously, you have a lot more variables. You can make your own questions and use them. Okay, so that brings us to the end of ANOVA. What we are going to do next is look at the last box that I had talked about. The weather's been horrible and my throat's gone for a partial toss, not complete toss, just a partial toss. And obviously with all the COVID going around, you never know what this is going to turn out to be. But anyway, so let's make that box one more time. And I won't make that box again till the end of the semester. Groups 1 to greater than 2. Questions 1 to greater than 2. One sample t-test. Paired sample t-test or repeated measures t-test, and now we are going to come to repeated measures ANOVA. Okay. Now repeated measures ANOVA, as I told you, I'm not going to test you on that on the finals, and you'll understand why. It's not really that it's very difficult, but given the time that you're going to have and everything else, access to SPSS, etc., I'm going to stay away from that a little bit and let you experiment with RMA for your projects. Again, I'm not expecting you to do RMAs, but obviously that if you do an RMA, if the question is important, you will be able to come up with better results. Okay, so more than 2 questions, one group of people. More than two groups of people, one question is an ANOVA. So these are the polar opposites of each other. Moving from here to here. So what is my alternate going to be? What is my null going to be? Okay. Now I'm going to assume that these are questions. As you will see, as you go forward, there might be something else. So the questions are importance of attributes. So I am looking at the importance of greater than two attributes at the same time. We've already looked at what is more important, comfort or safety. What is more important, speed or safety? We've already had a look at that, right? What we're looking at right now is amongst multiple questions, is there one question or are there multiple questions which stand out as being really high or really low? So you're looking at multiple questions together. As in an ANOVA, it's easier to write the H naught. What is H naught? Importance given to all attributes is the same. The same importance is given to all the attributes. Okay, what's your H naught? You can write it in, HA, you can write it in multiple manners. I'm going to go with importance given to all attributes is not the same. That's it, which means at least one attribute is given a different importance compared to all the others. Okay? That's it. That's all there is to writing an alternate. In terms of SPSS, what are we going to do? We are going to look at all the attributes together and try and figure out, is there one or two or three attributes which seem to be different from the others? Notice that it doesn't tell you which is the most important. It doesn't tell you what is the least important. It's just saying that one or two attributes or three attributes or five attributes are different from the others. So you're comparing each question against all other questions. So imagine the size of this comparison. So one is compared to 2, one is compared to 3, one is compared to 4, all the way till 12. Then 2 is compared to 1, 2 is compared to 3, 2 is compared to 4, and so on. So you're looking at a huge table. And that's why I am staying away from repeated measures ANOVA for your finals. Because if I give you an output which is 12 pages long, you're not going to be happy, I'm not going to be happy. Okay? So understand what it is, but I'm not going to test you on this. Obviously, in terms of your project, this is still on, not just cookie points, but it will probably help you in figuring out more strategies. So we are going to bid adieu to the tab that we have been playing with till now, which is compare means. We've looked at each and every one of these. That's not going to happen from now onwards. We're just going to look at one or two of each of the remaining tabs. So from there, we are going to move on to general linear models. Please do not move to generalized linear models, because if you do, that's going to be a huge attack on your self-confidence. So stay away from that. Still hurts me sometimes, so for you guys it's going to be very different. So general linear model, repeated measures. Before you get to your the box that you're comfortable with, which is your variable window, analysis window, repeated measures wants you to do something a little different. It wants you to set the scenario for it. Okay? Set the scenario for it. So how do you go about doing this? I'm going to give you two examples, one with the first and one with the attributes, and the second with, let's say we'll do values today. A few things that needed to be specified. Not everything needs to be specified, but it's good for you yourself to specify these, because it's easier to go back and look at what you've done. So what's a factor? In this case, let's not get into statistics. These are the questions that you're analyzing. What is the subject matter of the questions that you're analyzing? Like I said, it's only for you. SPSS is dumb and has no idea what you're typing in here. What are you analyzing? You're analyzing attribute. Let's do attributes. Okay. If you wrote Timbuktu in here, nobody would know. SPSS certainly wouldn't. This is being done so that you know what you're doing. And how many of them are you analyzing? This is the information that SPSS needs before it shows you the analyses window. So the number of questions that you're analyzing together, and what is the content of those questions. So you're analyzing attributes. In this case, if you were looking at questions 2 to 22, you would be analyzing issues. You would be analyzing values. You would be analyzing current attributes. So it's the number of questions that you're analyzing simultaneously, which in this case is 12. In that case, it would be 20. In this case, it would be 1, 2, 3, 4, 5, 6, 7, 8. In terms of, if you look at current comfort, there'll probably be about 12 again. Okay, so the substance of the question being asked, that goes into name, and the number of questions being asked is going to go into number of levels. The number of questions being compared is going to go into number of levels. The second part, not really needed, but I would suggest you do it just for yourself. What is it that these questions are measuring? These are a measure of X of attributes. Importance. These are measuring importance, and you can probably figure that out looking at the values that are given in here. They are measuring importance, they're measuring importance, they're measuring agreement, they're measuring satisfaction. So I am going to write importance. You don't need to write this, but again, it's going to be easier if you do. Nothing more than that. Click on define. You're back to your previous box. Back to your previous box. Now, on the other hand, all 12 boxes have been given to you. Okay. They have been created. So you need to tell them you are analyzing 12 questions. What are these 12 questions? You have told SPSS that you're analyzing 12 questions. What are these 12 questions? These 12 questions are car attributes here till here. If I wanted, I could have picked from here to here. Let's suppose these are 12, and SPSS would not have known any better. It would not have known any better in any manner or form. So you have to be very careful when you are doing this part. Make sure that you have the right questions that are being determined. Apologies, somebody decided to start mowing the lawn, so I just took half a second right. Okay, so back to where we were. So this is our setup. What we've said is we are going to analyze 12 questions together. These questions measure importance. Okay. These questions measure importance. And now the setup is ready. Now, before I go any further, just list down the steps that need to be worked at. Now, when you look at the output, it's voluminous. You're going to see a lot of information. The most important thing is that you're careful and you look at only two separate things. Okay, although the amount of output is going to be almost 13-14 pages, but we don't care about that. So the first thing you do is click on plots. That's step number one. Unlike in ANOVA, you can do all of these together. Okay. Sorry. On attributes, why does it say attributes? Because attributes is what? You named your questions. That goes on the horizontal axis. Once you are done with this, please make sure that you press add. Leave everything else be. Okay, I know this is very mechanical. Let it stay like that because we are not interested in the statistics again. We are interested in only the results that we get. Okay. Press continue. That's the first thing that you need to do. More for your own visualization than anything else. Okay. Second, we are not going to click on post hoc unless you are using an IBM version which is 24 or before. Okay. We are instead going to click on, this is IBM 26, this is SPSS 26 that I have. You might have 25. I'm hoping you don't have anything before 24. You click on EM means. Now, I'm not going to go into the details of which of these you need to use and why. We are going to go with a very simplified solution because the answer is going to be pretty much correct. Pretty much correct. You could go through a 5-step process and come up with the perfect answer. We are going to go with something simpler, which is going to be, we are going to click on attributes. We are going to display the means. But more importantly, please make sure that you do not click on overalls, you click on attributes. But most importantly, you have to click on compare main effects. If you were with me when we were going through a 12-week class, I would have walked you through all of these, the logic behind all of these. We are not going to do that. We are just going to use LSD, which is the default. We let it stay. So no adjustments whatsoever. Press OK. Continue. The third is options. And in options, you conduct, remember the variance test, the homogeneity of variance test, that's going to follow us for pretty much every single place in here. Out here it's called homogeneity test. We are going to click on homogeneity. Repeated measures ANOVA is probably, unless you go through the statistics, the most unintuitive test that you're going to go through. Is it important? Yes, it is. Okay. But most of the times, what we do is we look for other techniques, part of which you are going to be exposed to in this particular class in 2052, and you're going to look at other possible alternatives. But this is something which is used, which is why I go through it, but I'm not evaluating you on it. I'm not going to assess you on this. Press continue. Press OK. Now, there's going to be a lot of output. Don't worry about it. Just look at the ones that are important to us. Okay. First, it just tells me, the first box just tells me what? A simple thing, which is what are the questions being analyzed. That's all. So there were 12 questions being analyzed. That's where they are. Okay. I do need to look at the second box. Okay. What is the second box? The second box looks at the variation amongst each of the 12 answers. So is it that the first question, all answers are same or similar, whereas in the 12th question, everything is different. So that's the comparison that you're looking at. We don't need to look at the stats. All we care about is the first number, which is 0.000. Okay? That's all that we care about. Okay? What does it tell me? It tells me that the overall model is significant. What does it mean? Not too much, really. Okay. Not too much for right now. Let me come back to this in about 5 minutes. But this is a box that's relatively important. First important test that we get in this output. Call this step number 1. Step number 1, the first thing that you look at. I'm going through these sequentially, but that's not the way you're going to go. Mauchly's test of sphericity. What is this? It's checking if there's a difference across the questions in terms of variability. And in here, the number that's of importance to me is the significance. Okay? The number that is of importance to me is the significance. If this number is less than 0.05, if this number is less than 0.05, we look at the Hunefeld test, which is 0.000. If this number is greater than 0.05, we look at the sphericity assumed test. So this is the first step that you look at. It's a switch again, which tells you whether to look at sphericity assumed or Hunefeld. Okay. It's just two different tests being run. Are the results different? Most of the times they are not. Okay. Most of the times they are the same. But statistically, it's important to figure out which of the tests you should use. Now, I have completed step 1, which is looked at p less than 0.05 or greater than 0.05, and then step 2, where I figured out whether I want to look at the sphericity assumed or the Hunefeld test. Stop here for a second, take a breather. What does this second significance, which is the test of, and please forget about the name, test of within subject effects called? What is it important for? What is it telling you? This is your main test. This is what tells you whether or not the questions are rated differently. Not that, not this. This is not telling you anything about the HA. This is not telling you anything about the H0. This is not telling you about the HA. This is not telling you about the H0. What is telling you about the HA and H0 is this. What in here should I consider? Either the first row, if the p-value in here is less than 0.05, or the third row, first row if the p-value is greater than 0.05, or the third row if the p-value is less than 0.05. Okay. So this is just a switch. This is the first thing which is of importance to us, and this is what is giving us. What is it giving us? It's giving us whether or not your HA is correct. What is my HA? Let's go back and have a look. Sorry. What is my HA? Importance given to all attributes is not the same. Okay, importance given to all attributes is not the same. That's what my HA is. What is my H0? Importance given to all attributes is the same. Is the P, it doesn't make a difference which one is it. Is the P less than 0.05? Yes, it is. So what am I going to say? I'm going to say that I accept my alternate. So the test of within subject effects is the one that tells me whether or not your alternate is correct. Okay. I know the output is a lot, but just have to get used to it. The small little caveat, which probably is never going to happen, but there's a small little possibility, millions of a possibility, that if this significance is less than 0.05, and remember multivariate tests, and this is greater than 0.05, Pillai's trace, which is the first one, you can go with any of them, is greater than 0.05, then your results are invalid. But I'm going to ask you, although I have introduced multivariate tests to you, I'm going to ask you to ignore this. So what I'm going to do slowly is take away the useless bits of information, and there's going to be a lot of useless bits of information. Just keep the ones that are important. What about this one, test of within subject contrasts? Please delete it straight away. Not important. Test of between subjects, not important. So what am I left with? I'm left with Mauchly's test of sphericity, which was my first step. I'm left with test of within subject effects, which is actually something that's telling me about the HA, whether or not the HA is correct. Hopefully this looks a little easier now. Let's get rid of all of these. First step is Mauchly's step of hierarchy, sphericity. Hierarchy is different. Mauchly's sphericity test, which gives you a p-value. This p-value might be greater than 0.05 or less than 0.05. If it's greater than 0.05, you consider sphericity assumed. If it's less than 0.05, you look at Hunefeld, and this p-value tells you whether or not you should accept your alternates. Okay. Now we go further. What are these? These are just the means of the 12 attributes. Okay. Just the means of the 12 attributes, nothing over and above that. Do you need them? You probably do, but not something which is central to the tests that you're going to run. All it's telling you is what the means are. What is important to us is this huge table that we are going to get. Okay. What is this table? What is this table doing? In ANOVA, I was comparing group 1 with group 2, group 1 with group 3, group 2 with group 1, group 2 with group 3, group 3 with group 1, group 3 with group 2. In this case, I'm comparing question 1 with question 2, question 1, question 3, question 1 and question 4, all the way till question number 12. Then question 2 to question 1, question 2 to question 3, and so on up till number 12. So it's a comparison of all possible combinations. That's a lot of information. That's a lot of information. So what can I do with this information? What I'm going to do is look at the groups that are being formed. Okay. The groups of questions that seem to be similar and the groups of questions that seem to be different. Let's look at attribute 1. Is attribute 1 different from attribute 2? No star, so it's not. It seems to be different from 3, it seems to be different from 4, 5, 6, 7, not from 8, 9, 10, 11, 12. Okay. So it's different from pretty much everything except for 2 and 8. Question 1, 2 and 8 seem to be similar. All the others seem to be different. So 1, 2 and 8 seem to be forming a small little cluster. 1, 2 and 8. Okay. But what about 2? What is 2 different from? 2 is different from everything, including 8. But it's not different from 6. So the cluster becomes a little bit difficult to form. It's something which is abstract. So these clusters are overlapping each other. I can probably say that the most important attributes seem to be attribute 1, attribute 6, attribute 8, and this is something which is going to be easily visible from the graph. So the top ones seem to be 1, also 2 frankly, 6 and 8. The one that is way down in the boonies is number 12. Comparing all of these is very, very difficult when you have 12 questions. If these were 5 questions, if these were 4 questions, you might be able to form groups. With 12 questions, you can't form groups. It becomes very difficult. Look at number 12 though. Number 12 is different from every single thing. Number 12 is completely by itself in a league of its own. And it's negative for every single thing, which is people just don't care about it. And that's something that you can see in here. So the attributes that's different from all other attributes seems to be number 12. What is the most important attribute? The least important attribute is obviously number 12. It's different from all of the others. What's the most important attribute? 8. But 8 is not really different from 1. But it's different from everything else. So 8 and 1 seem to be the ones that seem to be on the top. Those seem to be the most important ones. They are different from most, not from everything, but they seem to be different from most of them. So I've been able to identify a few attributes which are different from some specific attributes. This is why when you're analyzing a lot of questions together, it becomes difficult to tease stuff out. So you probably want a smaller set of questions, which might be based upon your intuition, which might be based upon what you have learned. So let's do one more of these ANOVAs, repeated measures and ANOVAs, because setting this up, analyzing it, like I told you, is not a very easy step. So it's important to do this once or twice. Again, this is not going to be assessed in your finals. I'm going to get questions on this no matter what, but I'm reminding you, this is not going to be assessed on your finals. What we are going to do next, and I'm not going to walk you through the entire H0 and HA process. I am going to look at values. Do importance of values differ? How many values do we have? To the best of my recollection, we have 8 values. If they are wrong, if that number is wrong, I can go back and fix it. And what is it that values are looking at? Values, let's have a look. There you go. Values, and they're looking at importance. So let's go ahead and write importance in here. The importance of 8 values, importance is what we are considering. I'm going to define that. Oops, sorry. Let me go ahead and do that again. I forgot to press add. Okay, there you go. Okay, importance of those. I have to find it. There you go. Let's go to the values, throw all of them in together. Plot just for myself. 8 is also way too much. It's probably slightly easier than the ones that we were looking at, which were 12. No post hoc, again reminder, EM means. Make sure you click on values, not overall. Display means, which is not really necessary, but we need to compare main effects, which doesn't become available unless you display the means. So we've looked at EM means plots. There's one more left, which is options, and in options you click on homogeneity tests. Press OK. I'm going to delete everything that's unimportant. Within subject factors, just giving you a list of the questions. Everything is less than 0, so I can delete it. I am going to delete test of within subject, test between subjects. This is the only thing that we want. So let's have a look at Mauchly's test 0.000. If you have more than 3 questions, the chances of this not being significant are low, are really, really low. Okay. But anyway, since this is less than 0.05, what do we look at? We look at the Hohenfeld test 0.000, which means my HA is correct. What is my HA? There is a difference across the importance of the values. Which ones are important, which ones are not, I have no idea. We need to figure that out. So there are my means, and here are my comparisons. 1 is more important than 2, less important than 3, but 1 and 2, no star. So even if that number is positive, doesn't make a difference. Less important than 3, less important than 4, less important than 5, less important than 7, less important than 8. So 1 doesn't seem to be an attribute which is really important. 2, the ones which will have the most positives will be the most important. Which one seems to have the most positives? Let's go and have a look. This one still has a negative. This one still has a negative. This one has lots of negatives. This one has 1 negative. Number 8 is something which seems to have no negatives. And it's different from all the others. The 8th attribute, the 8th value is the most important. This is easy. The others are all mixed up, all jumbled up, but 8 seems to be standing out by itself. And it seems to be a number that's higher than everything else. Let's have a look at the graph. There you go. Number 8, whatever that value is, we'll go back and have a look, seems to be most important, seems to be more important than all the others. What about number 5? Number 5 seems to be very important too. It's different from all the others, but it's also less important than number 8. So in this case, I actually have a hierarchy, which is number 8 is the most important. Number 5 is second. It's still more important than everything else except for number 8. The others are all bunched together. Let's see if we can say that 2 is the least important. Let's go to number 2. 2, star, star, everything is negative with the sole exception of number 1. Number 1 and 2 seem to be the least important attributes, which is something which is visible in here. Okay? So 1 and 2 seem to be the least important. What about 1? 1 is not very different from 6. So can I say it's also very low in importance? It's low in importance, but statistically it is no different from 6. 1 is no different from 6. Okay? So I can very clearly say that 8 is the most important, 5 is the second most important, 2 seems to be less important, 1 and 2 seem to be the least important. Okay, so what are these attributes? I think I've deleted that, sorry. So let's go back and have a look. Self-respect is the most important attribute, is the most important value. Number 5, sense of accomplishment is, so number 8 was the most important. Sense of accomplishment is the second most important. The least ones seem to be being well respected. So I want to be, and this is what my values are, I want to have a sense of accomplishment for myself. I don't care about being well respected. Sorry, no. Sense of belonging. That wasn't making too much of sense. So sense of belonging is the least important. 1, which is fun, enjoyment, and excitement, also seems to be less important. Number 6 also seems to be somewhere in that line, which is warm relationship. So those are the less important ones. The most important ones being value, self-respect, and sense of accomplishment. Okay? So that is a repeated measures ANOVA. What we did today was look at 2 different types of ANOVAs. We'd already introduced ANOVA last time, and we went into that in a little bit more detail in terms of how to work with it, and we after that had a look at repeated measures ANOVA. Go through this a few times. You have 2 more sets of questions, which are the issues and current satisfaction. Try and run those both in terms of repeated measures ANOVA, where everything is thrown in together, or probably if you want to compare 3 or 4 questions together and try and figure out what the most important one is. That's based on your intuition. So you can try that rather than run all 13 of them together, rather than run all 20 of them together. A smaller subset based on what you think would be important versus what you think would not be important. Again, a reminder, so you will have a few tests that are going to be made available to you. So go through and work with those. Next week you will be able to participate. Next week or this week, I'll send you an email as soon as everything is done and fixed. You will be able to participate in the extra credit exercises that are being, I'm not really sure who's going to be administering those, but whoever it is, they'll have a small little snippet in there which will tell you what needs to be done. Okay? Both of them are going to be online surveys, and both of them I think require you writing a little bit, but again, I'm not absolutely sure about that. And again, please feel free to get in touch with me if you have any questions on MS Teams. Again, please try and not use Moodle, because Moodle is for contacting me, because that is the slowest of all possible media. Hopefully you'll have a good week. Next week we are going to have an online live lecture. Again, the best under given circumstances. But if you have any questions at that point of time, please feel free to keep on interrupting me, or after the whole thing is done, have a chat with me. Okay? All right, take care. Talk to you all later. Bye.